let's find the distance between two planes. So we have the equation for one plane and the equation for a second plane. And we want to show, first of all, that they're parallel, and then we want to find the distance between those parallel planes. So if you recall, the way we find if two planes are parallel is if they are normal to the same vector. And in that particular case, remember that the normal vector takes the coefficients of the variables for the equation of the plane. So I could say kind of n1 is 2I plus 7j plus 1k, and I could say n2 is 2I plus 7j plus 1k. Well, since they both have the same normal vector, we know that they must be parallel. Or at least, since their normal vectors are parallel, the planes must be parallel. Okay, well, since we know that, let's find the distance between them. So if you remember, the way that we would find the distance between them is we first get the point Q. Let's get that from this plane. Well, if I set x and y to 0, I get 0, 0, 9. And then now I'm going to get P. If I set x and y to 0, I get 0, 0, 13. And you're probably thinking to yourself, well, why are we even doing this? Like, those differences is 4, the distance difference is going to be 4. Well, let's find out. So remember, the way that we want to do this is we need to get PQ. So PQ is 0, 0, 4. And then we have the normal vector. And the normal vector is 2, 7, 1. And then we can do PQ dot n. And that gets me 0, 0, 4. And then we can find the magnitude of n. And that's 2 squared plus 7 squared plus 1 squared, which is the square root of 54, which is 3 square root 6. So then our distance is the absolute value of PQ dot n over the magnitude of n. So at that point, we would say that is 4 divided by 3 square root of 6. Which is kind of impressive. What that tells me is the distance is actually less than 1, even though the difference between 9 and 13 is 4.